Have you ever wondered how processes communicate in the world of parallel computing? Well, it's all about MPI, or Message Passing Interface. In this intriguing world, communication is pivotal. It's the lifeblood that keeps processes interacting and sharing data. But here's something even more fascinating. There are two types of communication in MPI: blocking and non-blocking. Blocking communication is like a diligent employee who won't leave their desk until the job is done. When a process sends or receives a message, it waits patiently until the operation is complete. On the other hand, non-blocking communication is the multitasker of the office. It initiates a communication operation but doesn't hang around waiting for it to finish. Instead, it continues with other tasks, checking back later to see if the operation is complete. So, when do we use each type? That's a question of efficiency and performance requirements. Stay tuned as we delve deeper into these two types of communication and understand their workings. Let's start by understanding blocking communication, where a process waits for the completion of communication. In the realm of Message Passing Interface, or MPI, this type of communication ensures that a process must wait for the communication to complete before continuing with its execution. It's like having a conversation where you wait for the other person to finish speaking before you respond. Blocking communication is divided into two types: blocking send and blocking receive. Let's delve deeper into each of these. First up is blocking send. Imagine you're sending a letter. In a blocking send operation akin to MPI_send, your process will not proceed until the letter, or in our case, the message data and associated metadata, have been moved into the system's internal buffer. This metadata includes details like the destination rank, tag, and communicator. It's like you're at the post office and you can't leave until the clerk has taken your letter, noted down the address and stamped it. Your process is effectively paused, waiting for this to happen. Next, we have blocking receive. This is like waiting for a reply letter to arrive. In a blocking receive operation, similar to MPI_ref, your process will wait, or be blocked, until the requested message has been received and placed into the provided buffer. It's like waiting at home for the postman to deliver your letter. The process will not continue until the message is received. So, to sum up, blocking communication is like a careful exchange of letters. In blocking send, your process can't continue until it's sure the message is on its way. In blocking receive, your process waits patiently for the message to arrive before it can move on. Now that we've understood blocking communication, let's move on to non-blocking communication. Non-blocking communication is where things get interesting. Here, a process initiates communication and continues execution without waiting. This approach can significantly boost program performance by allowing computation to overlap with communication. But how does this work? Let's break it down. Firstly, we have non-blocking send. Imagine you're sending a letter in the mail. In a traditional blocking send, you'd have to wait until the letter is delivered before moving on, but in a non-blocking send, you drop the letter in the mailbox and carry on with your day. The letter is sent in the background while you are free to do other things. In technical terms, a process initiates a non-blocking send operation, and without waiting for the send to complete, it continues execution. It's a multitasker's dream. Next up is non-blocking receive. To continue our mail analogy, let's say you're expecting a letter. In a blocking receive, you'd wait at the mailbox until the letter arrives. With a non-blocking receive, however, you initiate the receive operation and then go about your day, checking the mailbox only when you have the time. The process can perform other tasks while waiting for the message to be received. It's like having your cake and eating it too. So, to sum up, non-blocking communication in MPI is all about efficiency and flexibility. With non-blocking send, a process can initiate the send operation and immediately continue execution. And with non-blocking receive, a process can initiate the receive operation and continue execution, even if the data isn't available in the provided buffer yet. Now that we've understood both types of communication, let's look at how we can check the completion of non-blocking operations. With non-blocking communication, it's essential to check the completion status of initiated operations. This is where functions like MPI_wait come into play. MPI_wait is used with a non-blocking operation and will block the process until the operation is complete. Neat, right? But what if you want to test whether a non-blocking operation has completed without halting the process? That's where MPI_test comes in. It checks if the operation is finished, and if it is, it returns true and the process continues. If not, it returns false and the process isn't blocked. And for those times when you have multiple non-blocking operations to monitor, MPI has you covered with MPI_waitall, MPI_testall, MPI_waitani, MPI_testany, MPI_waitsum, and MPI_testsum. These functions allow you to check the completion status of multiple non-blocking operations, giving you a lot more flexibility and control. Now let's wrap up by discussing how to choose between blocking and non-blocking communication. Choosing between blocking and non-blocking communication depends on your specific use case and performance requirements. Let's delve into the advantages and disadvantages of each. Blocking communication shines in its simplicity. It waits for the communication to complete, making it easier to implement and understand. However, it might cause a process to pause in its tracks, potentially leading to inefficiencies. On the other hand, non-blocking communication can boost efficiency. How? By overlapping communication with computation. It means a process can carry on with other tasks while a message is being sent or received. Sounds great, right? However, there's a catch. Managing multiple pending operations and checking for their completion can become quite a task. So, weigh in these factors. Is simplicity your priority, or are you aiming for efficiency? And there you have it, a comprehensive look at communication in MPI. Remember, the choice between blocking and non-blocking communication depends on your specific needs and the performance requirements of your program.